about a system of inequalities in this lesson, 7-6. Please make sure you are taking notes. Make sure that you have yourself some type of a notebook that you can write your notes in, or you can have just pieces of paper and then put them in a folder, or if you took your binder home from school, you can put them in your binder. But you do want to keep these notes somewhere handy so that way you can reference back to them in future lessons if you need to. Do make sure you're also pausing lessons or pausing the videos as you're going. If you miss something, pause it, rewind it, slow it down, whatever you need to do to make sure you're understanding the material. So first, we need to just remind ourselves the names of our different types of inequalities. Okay, so these are your 4 inequality symbols. This first one up here is the greater than symbol. The next one is the less than symbol. If you were to hold up your 2 hands and kind of make sideways V's with them, you should see that your left hand kind of looks like an L, which also looks like the less than sign. So your left hand is the less than sign, and your right hand is the greater than. Underneath that, our next symbol looks just like the greater than sign, except it has the line underneath. That is your greater than or equal to. And then the last one, which looks like the less than sign, but a line under, so that is less than or equal to. So first thing that you need to make sure that you know when we start talking about a system of inequalities, get this stuff written down. Pause the video if you need to copy it all down. A system of inequalities is just a set of 2 inequalities. So back in 6, 7, you had just one inequality. You had something like y is less than 2x plus 3. That's an inequality. But now you're going to have a system, which means we have a set of 2. So I might also have y is greater than or equal to 5x minus 1. This is now a system because there's 2 of them. A solution is a point that is true for both inequalities. You would be able to test the coordinate point by plugging in the x value in for x and the y value in for y. If whatever you have for y is less than 2 times x plus 3, whatever that equals, then that one works, and you would check your other one also. Because we have a system and it is an inequality, there are going to be multiple solutions to each system. A system of equations had one answer. You saw by graphing it's where your 2 lines intersected. But in your system of inequalities, there are going to be an infinite number of coordinate points that will work for both. Okay, and we'll see what that looks like here a little bit longer with a graph. So first, let's just look at seeing if a certain point is a solution to the system. So we just said to be a solution to the system, your coordinate point has to work for both inequalities. So you should remind yourself x is first and y is second. So what you're going to do is you're going to test this coordinate point in the first inequality to start with. So I'm going to test the first inequality. It says y is greater than or equal to 1. So you're going to take your y value as 3 and plug it in for y. So I'm going to have 3 is greater than or equal to 1. There is nowhere for my x to go, so I don't need it for this first one. My left side is just 3, my right side is just 1. There's no work to have to do. I just see if this is true. It says 3 is greater than or equal to 1. Is that true? Yes, it is. 3 is greater than or equal to 1. If it's true, you now need to go on and check the second inequality. In order for it to be a solution, it has to work for both. So now we're going to check number 2 with the same way, just using our other inequality. So we're going to take our y, which we said is 3, and we're going to see if that is less than or equal to 2 times our x value is 2 minus 1. On the left side, we just have 3. is less than or equal, but on the right side, we need to work this out. We've got 2 times 2 minus 1. This is 4 minus 1 is 3. Is 3 less than or equal to 3? Yes, it is, because it says, is it less than or is it equal? And it is equal, so it is true. So is this coordinate point a solution to the system? Your answer should be yes, because it was true for both inequalities. It worked for the first one and it worked for the second one. Now our next question says to take a new coordinate point, 4, 5, and it wants to know if it's a solution to the same system. So the same inequalities we use back over here. So we're going to do the same process. We're going to take our x and our y value and plug them in for x and for y. Starting with your first inequality, you're going to take your y value as 5, plug it in for y. Is 5 greater than or equal to 1? Yes, it is. So now you're going to try the second one. You're going to take your y value, which is 5, is less than or equal to 2 times x, which this time x is 4, minus 1. So that is 5 less than or equal. 2 times 4 minus 1, 8 minus 1 is 7. Is 5 less than or equal to 7? Yes, it is. So is this a solution to the system? Yes. So, like I said before, you are capable of having multiple coordinate points that is a solution to the same system. Okay? Another example, is 5, 3 a solution to the system? So, start with equation or inequality number 1. 2 times x is 5 minus y is 3. We're going to see if that is less than or equal to 10. So we're going to do 2 times 5 minus 3. 2 times 5, 10, minus 3, 7. Is 7 less than or equal to 10? Yes. Now you need to check the second one. Take our y value is 3. Is that greater than 2 times your x value is 5? So we've got 3 is greater than 2 times 5 is 10. Is 3 greater than 10? No, it is not. So is this coordinate point a solution to the system? In this case, you should say no, because it only worked for the first one. It didn't work for the second one, and it's only a solution if it works for both. Last one like this. Is -3, -5 a solution to the system? So take your x and your y value. You're going to plug them into the first one first. So our y value is -5. We're going to see if that is less than 3 times our x value is -3 plus 1. So -5 is less than 3 times -3 plus 1 is -9 plus 1 is -8. Is -5 less than -8? No, it is not. -5 is not less than -8. So at this point, you don't even need to check the second one because we already know it doesn't work for the first one. So is this a solution? No, it is not. All right. Now we're going to talk about how to graph these. So back in 6, 7, you graphed an inequality. You graphed something like y is greater than 2x plus 1. When you graphed this, You obviously paid attention to your slope and your y-intercept. So we started at 1, and then your slope says you should go up 2 and over 1 each time. But then there was a certain type of line that you would use based on your inequality symbol. It was either a solid or a dotted. So these two symbols are both dotted. Greater thans or less thans are dotted lines. These two, greater than or equal and less than or equal, are solid. So because this is a greater than, I'm going to connect these dots with a dotted line. Now, you're not done with this because you need your solution set. So back in 6-7, you would pick a point up here and test it, and you would pick a point down here and you would test it. And whichever one worked is where you would shade. Maybe I picked this point and it worked, so I shaded up here. And this is my solution set. In our lesson now with the system, that's going to be very similar, except because we have a system, we have two equations. Sorry, two inequalities. Let me correct myself. Two inequalities. So now when you graph, and I'm just going to sketch a quick little graph that's not going to be very accurate, but give you an idea. This first one here would have some type of a dotted line. And the second one would have some type of a solid line. So we are going to have two lines now. There is still going to be one shaded solution area. Okay. So back over here, there was this part above and this part below the line. Now let me sketch a little bit better of a graph that doesn't go with those two, but so that you can see what it might look like now. Let's say this is your first line, and maybe here is your second line. There are 1, 2, 3, 4 sections. One of them gets shaded. So in this graph, maybe it's section 3 has all of the solutions to the system. I'm going to show you how to use Desmos to help you figure out where your shading is going to be. Okay, if I come to Desmos real quick, and I'm going to type in two inequalities. Okay, so here's my first one. So do you see how this red is where my shading is? That's my first inequality. Here's my second one, it's the blue one. So the system is both. Do you see how there's 1, 2, 3, 4 sections? The section that has both is your solution to the system. So this purplish color is the one section that is the solution to the system. Just red, just blue means it only worked for one. It is not a solution to the system. And white doesn't work for any. So this section over here is your solution area.